Okay, good morning. It's what day today? November 3, 2023. The time is 12:14 a.m. Okay, my topic for this morning will be a continuation of my subject matter, trigonometry, and we are now on lesson number 35. It's getting interesting because we are now through with the sine and cosine functions, that is the sum and difference. So for this morning, we'll try to derive the so-called subtraction formula for tangent. It's another variation of an identity that involves tangent. Okay, let's proceed. The subject matter for this morning will be a long video format discussion. It's not so long. What I call this, I make the discussion a little brief so you will not be bored. Okay. The subject matter for this morning will be trigonometry, lesson number 35, and the title of the topic is subtraction formula for tangent. We will be deriving this formula here. And practical application problems that involves trigonometric function, there come a time that we shall be using this formula, and to use this formula, I would like to bring out the derivation. It's better that we know how to derive it. So instead of just using the formula and we don't know where it came from, that's another thing. So if we can derive it, we derive it. So we present this before we'll try to solve problem using this formula here, the so-called subtraction formula for tangent. Okay. Let's try to bring out the derivation. This is just a simple one because we are now through with the so-called definitions, sine and cosine of the sum and difference. So we will be using that concept in the so-called derivation of the tangent of a difference. Okay, we shall start with this. We'll place the first angle to be x for the meantime, and the second angle will be y. Okay. So if we try to take the tangent of a subtraction, it should be a difference of x minus y. Okay. T should be equal to. What is tangent? If this is a minus b, okay, and this is what do you call this, x minus y, and this will be an x minus y also. Tangent is actually the ratio of the so-called, it's by definition, tangent is sine over cosine, right? The sine function over cosine. So tangent of the quantity x minus y can be written as, it's just like we are given tangent A. What is tangent A? It will be sine A over cosine of B. What is given here is x minus y, so tangent of x minus y will be sine of the quantity x minus y over cosine of x minus y. Okay, I will try to erase this one so it will look good. Right? So tangent is the ratio of a sine over cosine. And there will be a problem on how to expand this one. Right? But there's no problem because we are done with the expansion of this one, the sine of a difference. Okay? Like what I said, it will be sine cosine, cosine sine. If this is minus, this should be minus. And for the cosine, it should be a cosine cosine, sine sine. If this is minus, this should be plus. Okay? There will be no problem in this because we are now through with this one, right? I give you this one already. I even presented a problem involving this expansion here. That is, the sine of the quantity x minus y is sine of x cosine of y. If this is minus, this should be minus cosine of x sine of y. For the cosine, I got a code like what I said when I teach in the Philippines. That was 33 years ago, and I could still remember it because I got a code on how to remember the code. For a cosine, it should be cosine cosine, sine sine. If this is minus, this should be plus. So the cosine of the first angle, cosine of the second angle, plus sine of the first angle, sine of the second angle. Okay? Because upon taking the sine over cosine, if we do not know how to expand this one, we got a problem. That's why I presented first the equivalent of the sine of the quantity x minus y and the cosine of x minus y. Okay? So this will be the expansion of the numerator, the expansion of the denominator. Okay, let's try to do this. We'll divide all the numerators by a cosine x cosine y. Meaning, we'll take sine x cosine y, we rewrite it, and we divide it by cosine x cosine y. Okay? Minus. This is cosine x sine y, right? Cosine x sine y. Again, we will divide this by cosine x cosine y. Okay? All over. The denominator is actually the expansion, sorry for that one. Cosine x cosine y, I rewrite that one. Divided by itself, cosine x cosine y. This is plus. I will rewrite this one, sine x sine y. Again, we will divide this by cosine x cosine y. Why did we divide all the terms for both the numerator and denominator by cosine x cosine y? It's a rule in algebra. If you try to divide the numerator by a certain value, try to divide also the denominator with the same value, it will not change the value of the fraction. So this is actually cosine x cosine y, cosine x cosine y, cosine x cosine y, cosine x cosine y. There will be no problem with that one. Then try to make some cancellations. For the first one on the numerator, this is cosine y and cosine y. They will cancel out. Right? What remains is just the value of sine x over cosine x. For the second one, what will cancel out will be cosine x. Why it cancels? The operation on both the numerator and denominator are actually multiplication, so we can cancel. But just in case the operation here is plus, you cannot cancel. Since the operation for both the numerator and denominator are actually multiplication, we can cancel. So cosine x cancels. What remains will be the ratio sine y over cosine y. Right? For the total denominator, there will be two fractions, right? This is cosine x, it cancels out. Again, the operation here is multiplication we can cancel. Cosine y over cosine y, it will cancel. So in general, since cosine x and cosine x cancels and cosine y cancels, the total equivalent of this one will just be equal to 1. So this is now 1. Right? The second one, we must have to rearrange first. We'll take the ratio sine x over cosine of x. That's the first one. Okay? It's so-called, I think this is commutative. We will just change the, what you call this, the grouping, right? So, for this to be seen as a tangent, we'll take the ratio sine x over cosine x. Okay, there will be no problem with that. This is. For the second one, the ratio sine y over cosine of y. So the operation here is multiplication times sine of y over cosine of y. Right? But what is sine x over cosine of x? It's tangent. So this is tangent of x. The equivalent of sine over cosine will be tangent x. Same angle. It should be, the angle should be the same for it to be tangent x. Next one. What is sine y over cosine of y? It's still a tangent, but the angle should be y. So this is minus tangent. This is minus, right? Tangent of y. All over 1. This is now 1 because this whole quantity cancels, right? Cosine and cosine. What do you call this? Cosine x, cosine x, cosine y, cancels. So this is actually 1. This is 1. 1. And what is again sine x over cosine x? It is still tangent x. Right? And what is sine y over cosine of y? It will be tangent y. Okay? So if we now try to replace x by a and y by the value b, we will now be bringing out the general formula on how to compute or to solve for the tangent of a difference, right? So in general now, if we try to replace x by a and y by b, in general now, the tangent of a difference of two angles, a minus b, should be equal to the tangent of the first one minus the tangent of the second one all over 1. This is plus, right? Plus the tangent of the first one, tangent of the second one. So this is now a general equation. Try to memorize this by heart because this is one of the foundations of trigonometric identities involving the tangent of the difference of two angles. Okay? Oh, that's the derivation, complete derivation. Okay? So for as long as we are leaving, the tangent of the difference of two angles will be the tangent of the first one minus the tangent of the second one all over 1 plus the tangent of the first one, tangent of the second one. Okay? So that is actually the formula for subtraction of tangent of two angles. Okay? That's it. Okay? It's easy now because we know how to expand the sine and cosine function. That's why before proceeding with the tangent, at least we know the expansion of the so-called sine and cosine. Okay, this is Professor David J. De Los Reyes. Good morning from Los Angeles.